जय हिंद स्टूडेंट्स, कैसे हैं आप लोग। वेलकम टू माय यूट्यूब चैनल। स्टूडेंट्स, one of my favorite quote is the one that Lord Sri Ram tells Lakshman. We have no right to ask when a sorrow comes, why did this happen to me? Unless we ask the same question for every joy that comes our way. I repeat students, we have absolutely no right to ask when a sorrow comes, why did this happen to me? Unless and until we ask the same question for every joy that comes our way. So students, basically the essence of the above quote is that we need to accept and face the challenges that life keeps throwing upon us. We must not crib and instead find ways to overcome the obstacles and the hurdles that life keeps throwing at us. Right? So with that students, let's begin this session. Today we are going to discuss a very important concept. From numerical point of view, it's pretty important one. We are going to discuss the free body diagram and the numericals associated with it. So first and foremost, we need to understand the meaning of free body diagram. Like, suppose let's consider case A. This is case A and this is a system comprising of a pulley, right? This is fixed to a rigid support, and this is an inextensible massless string which is over the pulley, at the ends of which two bodies of masses M1 and M2 are suspended. Right? They are suspended free. So it's a system comprising of pulley and these two bodies of masses M1 and M2. Now students, free body diagram means a diagram for each body of this system depicting all the forces on that particular body by the different parts of the body, by the different parts of the system, is called the free body diagram. If I wish to draw the free body diagram for mass M2, then I need to draw a diagram depicting all the forces which are acting on mass M2 due to the different parts of the system. So that diagram would be called as a free body diagram. Right students? So before we proceed, let us recap or let us introduce some basic facts. First and foremost students, whenever we suspend a body with the help of a string, or for that matter a spring or a rod, right, then what happens is the body, due to its weight, that is force of gravity, it will always act in the vertically downward direction along the radius of the earth towards its center. That's the weight of the body. And equal and opposite force will be exerted on the string or on the thread in the opposite direction. Right? That's perfectly an action-reaction concept. So basically, a force which acts along this string towards the point of suspension, that will be known as the tension in the string or tension in the thread. Right? Suppose this is the body, it will exert or it will experience a gravitational force that is known as its weight, force of gravity, isn't it? So, if you hold a body with the help of a string, then that body will exert a force in the upward direction. That is reaction. And that reaction force, that is actually known as the tension. And tension, it always acts along this string towards the point of suspension. This is the point of suspension. So tension is a force which always acts along the string towards the point of suspension. And this is the same thread or the same string. So tension would be constant. Tension would be same. So this is it. Here also the tension at this point would be T. So remember students, tension is a force which acts along this string in a direction along its length towards the point of suspension. Right? So it is a force that acts along the length of the string towards the point of suspension. And second students, second important point, in all the questions, until and unless otherwise mentioned, we will consider the pulleys to be frictionless and massless. Since this pulley is not considered to be having any sort of mass, therefore no net force must be acting over it, isn't it? So we need not to draw the free body diagram of the pulleys. Clear? So we'll consider the pulleys to be massless and frictionless. Right? And third, the string, it is considered to be inextensible and massless. So these are the assumptions, students. Remember, pulleys are frictionless and massless. And second, strings are massless, having no mass or very negligible mass, and inextensible. And third, I have told you, tension. This is tension. It's a force which acts along the length of the string towards the point of suspension. Right? So third is the tension. T is a force that acts along the length of the string. That acts along the length of the string towards the point of suspension. Towards the point of suspension. So these are some of the points which you need to keep in your mind before attempting to draw the free body diagram. Right? Now let's consider case C. Let's draw the free body diagram. As I stated, students, free body diagram. This is a system comprising of these three bodies. We won't be able to draw the free body diagram of this pulley because it is considered to be massless, having no mass. Since net force is mass into acceleration. So if mass is negligible, then force acting on the pulley is 0. So no need to draw the free body diagram for the pulley, right? Which is massless. So let's consider the free body diagram for mass m1. This is mass m1. So free body diagram is a diagram for each body of the system depicting all the forces acting on the body by the remaining part of the system. So that's known as free body diagram. So on body M1, what are the forces acting? One is its weight, M1g. Other one is the tension, it is T, right? And suppose M1 is greater than M2. Let us consider. And let us consider the system to be moving in the clockwise direction like this. Now students, one thing to be noted is that we are aware S equals to ut plus half at square, isn't it? We know that S equals to ut plus half at square. Initially both the bodies are at rest, therefore u is equal to 0. Therefore S is equal to half a t square, or a equals to 2s by t square. Therefore, for a given time, acceleration is directly proportional to displacement. Always remember this. So in the case of fixed pulley, students, if this body goes down by 1 meter, the body M2 will also go upwards by 1 meter, taking the same time. So in the case of fixed pulleys, as indicated in the 4 diagrams, it's the case of fixed pulley, where the pulley is fixed to a rigid support, right? It is immovable. It is simply rotating about an axis, right? It will be only having rotational motion. It will not be having any linear motion. In such a case, students, both the bodies will possess the same acceleration. Why? Because for a given time, both the bodies will get displaced equally. Suppose this moves 1 meter downward, this body will move 1 meter upward, because the string under consideration is considered to be inextensible. So at the same time, both the bodies are covering same displacement. Therefore, acceleration of both the bodies must be same. So its acceleration is downward, while its acceleration of body M2 is upward. And both the bodies must be having the same acceleration, right? Okay, so its acceleration is downward. This is So this is the free body diagram of mass M1, right? The forces acting on it is M1G its weight, tension in the upward direction along the length of the string towards the point of suspension, and A is the acceleration, which is downward. The system, or rather the string, is coming downward like this. This body will move downward, this body will go upward. So students, as per Newton's second law, net force is equal to mass into acceleration. Isn't it? We are aware of this formula. Clear? The body is having a net acceleration in the downward direction. So what will be the net force? Always remember students, the body possesses acceleration in a direction along which the net force acts on the body. So net force must be acting in the downward direction. So M1G must be greater than T. And M1G and T are the two forces which are acting in the opposite direction. And whenever the two vectors acts in the opposite direction, then the resultant is given by the difference in the magnitude of the two vectors, isn't it? So what is the net force acting over here? It will be M1G minus T, because M1G is greater than T, because mass M1 is getting accelerated downward. So net downward force would be dominating, right? So what is the net force acting on this body? It will be M1G minus T. So this is the net force acting, and it will be downward direction because the body is having downward acceleration. It is equal to M into A. What is the mass of this body? M1. And what is the acceleration? A. Put this as equation number 1. So this is the free body diagram of mass M1, and this is the equation which we have constructed using the free body diagram, right? Now let's try for body of mass M2. Let's consider the free body diagram of the second body, which is of mass M2. Okay, let's draw the free body diagram in the similar manner, right? This one. This is M2. What are the forces acting? One will be its weight, which will always act in the vertically downward direction along the radius towards the center of the earth, and this is the tension acting over here. This is the tension. In this case, this body is getting accelerated in the upward direction. So this is the free body diagram of mass M2, right? Again, as per Newton's second law, net external force is equal to mass into acceleration. We are aware of it. So, out of T and M2G, which one is dominating one? T must be dominating because the body is getting accelerated in the upward direction. And again here, T and M2G are opposite directed. That is, the angle between them is 180 degree. Therefore, the resultant of T and M2G, as per the laws of vector addition, would be given by the difference in the magnitude of the two vectors, right? So, what will be the resultant force acting over here in the upward direction? It will be T minus M2G. Why T minus M2G? Because T is greater than M2G. Why T is greater than M2G? Because the body is getting accelerated in the upward direction. The net force acting on the body, the direction of that net force would be same along the direction in which the body gets accelerated. So these two are in the same direction, right? So net force is T minus M2G. It would be equal to mass into acceleration. Mass of the second body is M2, and this is A. Put this as equation 2. Now students, we have got two variables, T and A. These are the two variables, and we have got two equations. So we can make use of these two equations so as to get the expression for the acceleration of the system as well as the expression for the tension in the string, right? Let's solve it. If we add these two, adding 1 and 2, what we get is M1G minus M2G, right? M1G minus M2G. Minus T plus T get cancelled. So it will give us M1A plus M2A. Am I clear, students? So here in the terms we get acceleration, it will be equal to M1 minus M2 divided by M1 plus M2. Here A can be taken as common, so inside bracket it will be M1 plus M2 multiplied by, here G is common. So rearranging the terms, we get aspiration, it is equal to M1 minus M2 divided by M1 plus M2 multiplied by small g, which is the acceleration due to gravity. So you need to remember this formula, students. We'll be making use of this formula directly in solving the other three questions, right? So in such a scenario, where the pulleys are considered massless and frictionless, in that case, if the two bodies are suspended freely and the string is also considered to be inextensible and massless, then the acceleration of each of the two bodies is given by M1 minus M2 divided by M1 plus M2 multiplied by small g. Here obviously M1 is greater than M2. Right, students? So this is the expression for the acceleration. Now in order to get the expression for the tension, what we need to do is simply substitute this value in either of these two equations. Right? In either of these two equations. So from equation 1, what we get is M1g minus t is equal to M1. Substitute this value of A over here. It will be M1 minus M2 divided by M1 plus M2 into g. Right? So t would be equal to M1g minus M1 minus M2 divided by M1 plus M2 into g. On further solving, M can be taken as common. In fact, M1g can be taken as common. So here it would be 1 minus M1 minus M2 divided by M1 plus M2. Clear, students? So if you solve further, what we get is simply try to rearrange the terms. Let's see what we get. So tension, I'm writing it over here. Tension, it would be equal to M1g. LCM is M1 plus M2. M1 plus M2. Here it would be M1 plus M2 minus M1 minus M2. Isn't it? So T would be equal to M1 minus M1 get cancelled. So M2 plus M2, it would be twice M2. So what we get is twice M1 M2 divided by M1 plus M2 into G. So these are the two very, very important formulas which you need to remember, students. We have derived it using the two equations which we obtained using free body diagram, but this is the result which you need to remember. Right? So the acceleration of each of the two bodies is M1 minus M2 divided by M1 plus M2 into G, and the tension of the string is given to be twice M1 M2 divided by M1 plus M2 into G. Right, students? So now let's try, or rather let's attempt the other three questions. I'm again telling you, students, in the next three questions I'll be making use of these formulas directly, which we have proved in this question number 1. Right? Okay. So let's try the second question then. Just concentrate on that particular diagram. So first and foremost, logically what we'll do is, we'll simply try to convert the system into this one. Right? Since the strings are given to be massless, so what we can do is, we can convert it like this. This is the pulley under consideration. Okay. Here it is 2 kg. And over here, students, what we can do is 3 plus 1, we can write it as 4 kg. Right? So this gets reduced in this particular form. And here we are supposed to find out the tension in this string. Suppose this tension is T. This is the same string, right? So tension will be same. This was different one. So this is T dash, suppose. We'll discuss the free body diagram of this. So we need to find out the tension T, T dash, and the acceleration of each of the three bodies, right? So that diagram gets reduced to this particular diagram. 4 is greater than 2, so obviously it will get accelerated in the downward direction like this. So, as I told you in the first question, since it's the case of a fixed pulley, therefore, in a given time, both the bodies will have equal displacement, so that the acceleration of both the bodies would be same. If it moves 1 meter downward, it will also move 1 meter upward during the same time. So acceleration would be same for both the bodies, right? Because acceleration for t equals to constant for a given time, acceleration is directly proportional to displacement, right? So your acceleration for both the bodies would be same. The only difference would be in its direction. Its acceleration will be downward directed. It will have the same acceleration but directed upwards, right? So students, we are aware of this value of A. What's the formula for A? It is, these are the two formulas to be used. M1 minus M2 divided by M1 plus M2 into G. And tension, it is twice M1 M2 divided by M1 plus M2 into G. Clear? These are the formulas which were derived in the case 1. These are the formulas which we'll be using in rest of the questions as well, right? So here, what will be the acceleration? M1 minus M2. M1 is greater than M2. So 4 minus 2 divided by 4 plus 2. And we'll consider the value of small g as 10. Take g as 10 meter per second square. Taking g as 10 meter per second square, right? So in a single step, we can determine the acceleration. So it will be equal to 2 divided by 6 into 10. So that will give you 10 by 3 meter per second square. So students, that's the acceleration. All the three bodies will have the same acceleration. These two bodies will have acceleration in the downward direction, and this body of mass 2 kg will have acceleration in the upward direction, right? And the magnitude of the acceleration is found to be 10 by 3 meter per second square. All the three bodies in a given time will have the same displacement. Therefore, the acceleration of all the three bodies is constant, right? So each being 10 by 3 meter per second square. Let's find out the tension. Let's find out the tension, this tension, this T. So it will be equal to twice M1, M2. That diagram has been reduced to these two, right? M1, M2, M1, M2. 4 into 2 divided by M1 plus M2. That is 4 plus 2 into G. G is considered to be 10. I am making use of this formula. So tension would be equal to 16 divided by 6 into 10. Right? So it is 80 by 3 Newton. So this is the tension in this string. So T has been calculated. This T. The tension in the string is 80 by 3 Newton. Right? 26.67 Newton. 80 by 3 is 26.67. Now students, we need to find out the value of T dash. For that, you can draw the field body diagram of either mass 3 kg or of mass 1 kg. You should get the answer of T dash then, right? Let's try to draw the field body diagram of this case. For 3 kg mass. Let's draw the free body diagram. This is 3 kg mass. It is having acceleration in the downward direction and its value is given to be 10 by 3 meter per second square. Its weight will act in the downward direction. mg, that is 30 Newton, this will be the weight. And this is T dash. Right? This is the free body diagram of body of mass 3 kg. Right? 30 Newton is the weight. Weight is m into g. Mass is 3 and g is considered to be 10 meter per second square. So this is the free body diagram of mass 3 kg. So now let's construct the equation. These two are opposite directed, and 30 Newton must be greater than T dash because the body is having acceleration in the downward direction. So what will be the equation? 30 minus T dash, it is equal to mass into acceleration. 30 multiplied by 10 by 3. Mass is 3 actually. 3 into 10 by 3. It's clear, students? So what we get is 30 minus T dash is equal to 10, or T dash, it will be equal to 30 minus 10, which will be equal to 20 Newton. So the tension in this string is 20 Newton. The same answer can be obtained also by making use of the equation by drawing a free body diagram of mass 1 kg. That is an optional one. Let's try that as well, right? Okay. Let's try to obtain the same result by using body of mass 1 kg. Okay, let's check it out. This is an optional thing which I am just trying to cross check the answer. Okay, for 1 kg mass, right? 1 kg. This is the body of mass 1 kg. What are the forces acting over here? One is T dash. This is T dash. Its weight 1 into G, that is 10 Newton. And the upward force is T. And it is having acceleration in the downward direction. This is a free body diagram. Look, students, whatever force is exerted by 1 kg on 3 kg mass, the same force will be exerted by 3 kg on 1 kg mass. So this is action-reaction, T dash. And they act on different bodies. This T dash is acting on this body while this T dash is acting on 1 kg. So they form action-reaction pair, isn't it? And so what are the forces acting on 1 kg mass? One is this tension T dash, which is the force exerted by 3 kg on 1 kg, right? The other will be its own weight. Weight is m into g, mass is 1, small g is 10, so it will be 10 Newton, it's the weight. And this tension, it's in the upward direction, right? And it is experiencing acceleration in the downward direction. So how do you calculate these three forces? Make use of laws of vector addition. These two are in the same direction. So they will get added up, T dash plus 10 in the downward direction. And T is in the upward direction. Net acceleration is in the downward direction. So downward force must be dominating one. Therefore net force acting on this body would be T dash plus 10. Why plus? Because both are acting in the same direction. Minus T. Why minus? Because T is acting in the opposite direction, 180 degree. This is the net force acting on this body. And as per Newton's second law, net force acting on a body is mass into acceleration. What is its mass? 1. What is its acceleration? A. A is found to be 10 by 3. I hope you have understood this. Now you can easily solve it and get the answer. So let's try. T dash plus 10 minus tension. T is found to be, I think, 80 by 3 is equal to 10 by 3. So T dash, it will be equal to 10 by 3 plus 80 by 3 minus 10. So 3 can be taken as LCM. So 10 plus 80 minus 30. So that will give us, students, 60 by 3. And that is equal to 20 Newton. The same which we have obtained by constructing equation using the free body diagram of mass 3 kg. So students, it's entirely up to you to consider the free body diagram of either of these two bodies. Clear, students? So this is how, by using the concept of free body diagram, such questions can be easily solved. The tension in each of the string can be easily determined. The acceleration of each of the body can be easily found, right? Okay, students, now let's try this question. See, right? Two bodies. These are the two bodies of equal masses. They are connected with the help of the string which is over this pulley, which is frictionless and massless. And the string is considered to be inextensible and massless, right? So the question is, what percentage of mass must be transferred from one body to another body so that both the masses move 50 meters in 5 seconds. Initially, these two bodies are at rest, right? So what percentage of mass need to be transferred from one body to another body? So this is the question where we will make use of the formula directly, which we have done in case A, right? We know that in this case, the acceleration of the system, as you are aware, if m1 is greater than m2, it's given by m1 minus m2 divided by m1 plus m2 into g. Right? This is the formula. Let's make use of it. Now also suppose let m dash be the amount of mass that is transferred from, say, this body to that body, right? From one body to another body. So if m dash be the amount of mass that is transferred from this body, so this body now will have a mass which will be less than its initial mass. Now it can be written as m minus m dash. Am I clear, students? M dash mass is being taken from it and it is added to the other body. This mass of this body will obviously get enhanced or it will get increased. Suppose now its mass is increased to m plus m dash. Am I clear, students? So obviously, now the system will start moving along this direction, isn't it? So the acceleration of this body will be in the downward direction, the acceleration of this body will be in the upward direction. Clear? Weight of this body, it will be m plus m dash into g. This will be the tension. Here the weight of this body would be m minus m dash into g, and same will be the tension here as well, right? So this is it. So now, students, acceleration would be along this direction, obviously. And as I told you, for t is equal to constant, the acceleration of each of the body in a given system is directly proportional to displacement. So both the bodies obviously will cover equal displacement in equal time, equal displacement in a given time. Here, both the bodies are covering 50 meter distance in 5 seconds. One in the downward direction obviously and the other one in the upward direction. So in a given time, both will cover the same distance. Therefore, acceleration of both the bodies is constant. But for this body, acceleration directed downward. For this body, acceleration directed upward. Right? So let's substitute this value of A. So A would be equal to m1 minus m2. m1 is greater than m2. So this one will be m1 and this will be m2. So let's substitute this value. m1 is m plus m dash minus m2. m2 is m minus m dash divided by m1 plus m2, that is m plus m dash plus m2, that is m minus m dash into g. Clear, students? So we need to consider the value of A then by using this data, 50 meter in 5 seconds. So now what to do is, as we are aware, S equals to ut plus half at square. Consider any one of the two bodies. Initial velocity is 0. Time is 5 seconds. And the distance covered by each of these two bodies is 15 meters. Substitute this value over here, the acceleration can be easily calculated. So let's see, 50, it's equal to ut will become 0, half a t square, 5 square. So students, acceleration, it will be equal to 100 divided by 25. So it will be equal to 4 meter per second square. Right? Let's get the answer now. So substitute this value, a as 4. Solve it. What we get is n minus m get cancelled, m dash minus s plus m dash, it will give us twice m dash. Divided by m dash minus m dash get cancelled, we will get twice m. Into small g, take small g as 10. Right? Take small g as 10 meter per second square. So what do you get? M dash by M, it is equal to 4 by 10. Therefore students, M dash by M is the fraction of mass that is transferred from one body to another body. In order to convert it into percentage, we'll multiply it by 100. So it will be 4 by 10 multiplied by 100. So it will be equal to 40%. So this is the answer. M dash by M is the fraction of mass that is to be transferred from one body to another body. So M dash by M multiplied by 100 would be the percentage of mass that is to be transferred from this body to that body, so as to have an acceleration of 4 meters per second square. In other words, so as to make each of these bodies move 50-meter distance in 5 seconds. So that is how this question is to be done, right? This is indeed a very, very good question. Okay, let's proceed to question number D then. We'll do or try to attempt the last question also by using the formulas which we have derived in question number 1, question A. Okay, let's try to solve it. We are supposed to find out the acceleration. Now, 20, 10, it will give us 30, and 6, 4, it will give us 10. So first and foremost, students, first step is to try to reduce this diagram in this form. This is a system comprising of these two bodies suspended with the help of an inextensible string. So what to do is, let's try to first convert it into this type of diagram. So this is 20 plus 10 and the mass of the string is considered to be negligible. So what we can do is 20 plus 10, it can be replaced by a body of mass 30 kg. Right? Here it's 6 plus 4. So it can be assumed to be replaced by a body of mass 10 kg. So this portion gets reduced to this one. And this is the tension T. This is considered to be tension T. Clear? This is tension T. Obviously 30 is greater than 10, so it will have an acceleration in this direction clockwise. So again, in the same time both the bodies will cover the same distance, so it will have the same acceleration. Right? So what will be the force acting over here? 30G. Over here the weight would be 10G. Right? No need to draw the free body diagram over here. Since it has been reduced to this form, we can make use of the formulas directly. So, acceleration. Students, this is the formula which we will be using. m1 minus m2 divided by m1 plus m2 into g. Right? And the tension, it is twice m1 m2 divided by m1 plus m2 into g. Here obviously m1 is greater than m2 and we will consider g to be 10 meter per second square. Right? So let's substitute the value here. A, it is equal to m1 30 minus m2, its mass is 10, divided by 30 plus 10 into the value of g can be taken as 10. So acceleration, it will be 20 by 40 into 10. So it will be equal to 5 meter per second square. So very simple, students, isn't it? So the acceleration in this system of each of these four bodies would be 5 meter per second square. Right? Now let's find out the tension in the string. It is twice into m1 m2. m1 is 30, m2 is 10. Twice into 30 into 10 divided by 30 plus 10 into 10 g. So let's solve it. So t would be equal to twice into 30 into 10 into 10 divided by 40. 0, 0 get cancelled. So 300 to 600 by 4, isn't it? So that will give us 150 Newton. So this is the tension acting in this part of the string, this part. Clear? Now suppose we need to calculate the tension in this string. So it will be T dash and this will be also T dash. This forms action-reaction pair. So in order to find out the tension T dash in this string, we have to draw the free body diagram of mass 20 kg. So let's try. Okay, what we'll do is, let us try to draw the free body diagram of 20 kg for 20 kg mass. Let's draw the free body diagram. Okay, this is it. This is 20 kg. Force acting over here would be 200 Newton. This is the weight of this body. This tension is T dash, this T dash, and it will be accelerated in the downward direction. So students, we can easily construct the equation. 200 must be greater than T dash, isn't it? So net force acting on 20 kg would be 200 minus T dash is equal to mass into acceleration. This is the net force, and as per Newton's second law, net force acting on a body is mass into acceleration. Its mass is 20, acceleration is 3. So let's substitute the value. So T dash, it will be equal to 200 minus 20 kg. So that will give us 200 minus 20. Acceleration of each of the four bodies is determined to be 5 meter per second square. So substitute the value of A as 5. So that will give us 200 minus 100. So T dash, it will be equal to 100 Newton. Right? So the tension acting on this string, which is between the bodies of mass 10 kg and 20 kg, is 100 Newton. Right? Okay. Let's consider, or rather let's find out the value of tension T double dash. For this, students, you need to draw the free body diagram of mass 6 kg. Let's do it. For body of mass 6 kg. Okay, this is the body of mass 6 kg. What are the forces acting on it? In the upward direction, T double dash, and its weight, it will be 60 Newton, and obviously it is getting accelerated in the upward direction, isn't it? So this is the acceleration, and we have determined its value to be 5 meter per second square. So we can easily construct the equation and solve for T double dash, right? So net force is acting in the upward direction, so T double dash must be greater than 60, and T double dash and 60 being opposite directed, net force acting on 6 kg would be T double dash minus 60. This is the net force acting on this body. And net force is equal to mass into acceleration. Mass of this body is 6 into A. Therefore, T double dash would be equal to 6. The value of A is 5 plus 60. So T double dash, it would be equal to 30 plus 60, and that is equal to 90 Newton. So students, in question number 4, we have determined the value of T dash, we have determined the value of T, we have determined the value of T double dash, and also we have determined the value of acceleration of each of the four bodies. Isn't it? So this is how, by making use of free body diagram, you can easily find the acceleration of the bodies constituting a system. As well as they can also determine the value of tension in the string. Tension is a force that always acts along the length of the string towards the point of suspension. Here you might wonder why I have not shown the forces acting on this pulley. It is because, students, in the earlier, before we have started doing these numericals, we have assumed that the pulleys are considered to be massless and frictionless. Right? So in case the pulley were given to be having some finite mass, then the forces acting would have been, suppose the mass of the pulley is n dash, then the forces acting on the pulley would have been its weight and the tension which would have acted along this direction. They must have formed action-reaction pair. Isn't it like this? Anyway, we will discuss the questions involving the pulleys which are having some finite mass in the coming lectures. Right? For the time being, to start with, we have considered the pulleys to be massless and frictionless. That was the assumption which we have considered while attempting all these 4 questions. I hope students you have enjoyed a lot doing these type of questions, right? Do practice as many numericals as possible. So do join me in my next lecture. I'll be coming up with some more additional numericals, right? So till then, do take very good care of yourself and thank you.